Hello everyone, in this video we will explore topic 8.4 error between curves with respect to x. I consider the following graphs y equals f of s and y equals g of s that continues on the interval 1 and 3. Alright, so look at this one, 1 right here and 3 right here. Alright, so this one is the intersection and this one is the intersection, right? So we need to calculate the pin error right here. Alright, so does that mean you're gonna take the error of the region under f of s, right? Which means the green one right here. Subtract the error of the region under the function g of s right here, right? Which is the blue one right here to get the pink one, right? So does that mean the interval form 1, 2, 3 of the function f of s subtract g of s, right, equals the interval form 1, 2, 3 of f of s ds subtract the interval form 1, 2, 3 of g of s ds, right? In other words, if f and g are continuous on the closed interval a and b, and if g of s less than or equal to f of s, what does it mean? It means that g of s is below the function f of s, right? For all s in the closed interval a and b, then the error of the regions bounded by the graph f and g and the vertical lines s equals a and s equals b is given by the formula right here. Alright, where a and b are intersections between two graphs f of s and g of s. Alright, here's the easy way for you to memorize the formula. Alright, the interval from s1 to s2. Take the top curve, subtract the bottom curve. Alright, with respect to s, keep that in mind. Alright, so look at this diagram right here. The function f of s and g of s intersect as this guy and this guy. Right? We need to calculate the error of the shaded regions. Alright, so how do we do that one? I'm gonna call the intersection right here as S1. Right? I call the intersection right here S2. Right? So basically from A to S1, the red one right here, which is the function f of s right here, is above the function g of s, right? So it's going to be the integral from a to s1 of f of s subtract g of s ds, right? Now, from s1 to s2, g of s is above f of s, right? So it could be plus the interval from s1 to s2, g of s subtract f of s ds, alright? And the last one, the interval from s2 to b. F of s is above g of s, right? So it could be plus the interval from s2 to b. F of s subtract g of s ds. Alright, so keep that in mind. Alright, let's take a look at the first example. Find the error of the regions bounded by the graphs y equals s squared plus 2, y equals negative s, s equals 0, s equals 1. Sketch the graph and shade the regions. Okay, so basically you need to graph this one first. Alright, so s equals 0, y equals 2. Right, this one is the vertex, right? S equals 1, y equals 3. S equals negative 1, y equals 3. Right, so the graph should look like this. Now, y equals negative s. It's going to be something like this. Alright, now, the lower bound is 0, the upper bound is 1, right? So 0 is right here, upper bound is right here, right? So it's going to be these regions. Alright, so the error should be the interval from 0 to 1. The upper curve, which is y equals s squared plus 2, right? Subtract the lower one is y equals negative s, right? Subtract parenthesis negative s ds, right? So it's going to be integral from 0 to 1, s squared plus s plus 2 ds, right? Now you're going to take antiderivative of this one. It's going to be s cubed times 1/3, right? Plus 1/2 s squared plus 2s, right? Evaluated from 0 to 1. Now substitute the upper bounds right here. It's going to be 1/3 plus 1/2 plus 2. The lower bound is going to be 0, right? So this guy turns out to be 17/6. This one is the final answer. Alright, let's take a look at example number 2. Now we need to graph this guy and this guy. Alright, so y equals negative s squared plus 2, right? So s equals 0, y equals 2. It's going to be right here. S equals 1, y equals 1, right? So it could be right here. S equals negative 1, y equals 1, right? So it could be something like this. Alright, so the shaded region should be this guy. Now observe that example number 2 is slightly different from example number 1. Why? Because you don't have the upper bound and lower bound, right? This one is given upper bound and lower bound right here, right? This one doesn't have it. So how do we do it? We need to find it, right? So we need to find the intersection between two graphs. It's going to be right here and right here. In other words, we need to solve a system of two equations. The first one is y equals 2 minus s squared, right? And the second one is y equals s right here, right? So we just let this guy and this guy equal. So we have 2 minus s squared equals s, right? So we need to solve for s. So it's going to be s squared plus s minus 2 equals 0, right? We're going to factor this one out. So it's going to be s minus 1 times s plus 2 equals 0, right? So this one is the 0 product. So s minus 1 equals 0. And s plus 2 equals 0, right? Then s equals 1. S equals negative 2, right? So this could be negative 2 right here, and this could be 1 right here. This is exactly right. Alright, so the error should be the integral from negative 2 to 1. The upper function subtract the lower function, right? So upper function is this guy right here. So you have 2 minus s squared. Subtract the lower one is this one, right? ds. Alright, now you're going to take antiderivative of this one. It's going to be 2s minus 1/3 s cubed minus 1/2 s squared, right? Evaluated from negative 2 to 1. Alright, substitute 1 over here. So we have 2 minus 1/3 minus 1/2. Substitute negative 2 over here. It's going to be negative 4 plus 8 over 3 minus 2. Alright, if you simplify this one, it's going to be 9 over 2. This one is the final answer, right? Now let's take a look at example number 3. Find the error of one of the regions, alright, bounded by the graphs y equals psi s and y equals cosine s. Sketch the graph and shade the regions, alright? So basically, you need to sketch y equals psi s and y equals cosine s, right? Now remember, you learn how to graph these two functions in AB pre-calculus, right? The period of these two functions is 2 pi, right? Now take 2 pi divided by 4. Alright, so it's going to be pi over 2 is 1/4, right? Now you know that the sine function starts from the origin, right? Go up to the maximum in the first quarter. Go back to the midline, right? And go down to the minimum and back up to the midline, right? So it could be something like this. Remember, the sine and cosine function have the same maximum and minimum. It could be 1 and -1, right? Now, for the cosine function, the cosine function starts from the maximum, right? So it starts from here, right? Go down to the midline, right? Go down to the minimum, back up to the midline, go back to the maximum, right? So it could be something like this. Now you need to find the intersection between two graphs, right? The first intersection right here, and the second intersection is right here, right? And the shaded region should be this one. Now I'm going to show you how to find the intersection points without the calculator, right? So you just equate this guy and this guy, right? So we have sine s equals cosine s, right? Divide both sides by cosine, so it could be sine s divided by cosine s equals 1, right? Remember that cosine must be different from 0, so that when you divide both sides, it's going to be divided, right? And then sine divided by cosine, it could be tangent s equals 1, right? So s equals pi over 4 plus k times pi, right? Where k is the integer, right? So first, k equals 0, s equals pi over 4, right? Which is right here. And k equals 1, s equals 5 pi over 4, which is right here. The error of these regions is the interval from pi over 4 to 5 pi over 4, right? The upper one subtract the lower one, right? Upper one is the sine function. The lower one is the cosine function, right? So it could be sine s subtract cosine s ds, right? Now, you're going to take antiderivative of sine s, it could be negative cosine s, right? And antiderivative of cosine s is going to be sine s, right? So it could be minus sine s. Evaluate from pi over 4 to 5 pi over 4, right? Now, I have negative cosine of 5 pi over 4, subtract sine of 5 pi over 4. Then subtract the lower bound right here, it's going to be negative cosine of pi over 4, subtract sine of pi over 4, right? Alright, now we're going to simplify. Alright, now we're going to use the unit circle. It's right here. This one is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4 right here. Alright, this one is the cosine axis. This one is the sine axis, right? So cosine 5 pi over 4 equals negative root 2 over 2, right? So, and then you have the negative side right here, so it becomes root 2 over 2, right? Now, sine of 5 pi over 4 is going to be negative root 2 over 2, right? Right here. And combined with negative side right here, it becomes root 2 over 2. Subtract. Cosine of pi over 4 is going to be root 2 over 2, right? So, negative becomes positive, right? Root 2 over 2. Now, sine of pi over 4 is going to be root 2 over 2, right? Negative becomes positive, so it could be root 2 over 2. So we have 4 root 2 over 2. It becomes 4 times root 2 over 2. Alright, so it's going to be 2 root 2 is the final answer. Alright, now you can use the calculator to check your work, right? So you're going to print up the calculator at graphs right here. First, you're going to hit sine s, right? You hit enter. The answer is right here. Alright, now you're going to graph the cosine function. So you're going to hit tab, put cosine function, check cosine as, hit enter. The answer is right here. Alright, now you need to find the intersection between this guy and this guy right here. Right? So you're going to hit menu, analyze graph, intersection right here. The answer is 0.785, right? Similarly, hit menu, analyze graph, intersection right here. The answer is 3.93, right? And you know that within this interval, the sine function is above cosine function, right? So you're gonna go to the home screen and you hit calculate right here. Hit menu, calculus, the interval right here from 0.785 to 3.93 of sine of s. Subtract cosine of s ds. Hit enter. The answer is 2.828. This guy is exactly of 2 times square root of 2. Convert this one to decimal, you will see it, they're both the same. Right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.